Summary: three species in aqueous solution are taken to mean the same thing: the proton hydrogen cation H+, which is hydrogen atom without an electron, and the hydronium ion H3O+, which is water chemically bonded to a proton. An Arrhenius acid produces protons in water, while a Bronsted acid is a proton donor. A conjugate acid is a Bronsted base attached to a proton. One monoprotic acid can donate one hydrogen ion, while one polyprotic acid can donate more than one hydrogen ion. An Arrhenius base produces hydroxide ions in water, while a Bronsted base is a proton acceptor. A conjugate base is a Bronsted acid without a proton. One formula unit of a monobasic base produces one hydroxide ion, while one formula unit of a dibasic base produces two hydroxide ions. Strong acids and bases are strong electrolytes that are totally ionized in water, while weak acids and bases are partially ionized in water. A strong acid has a large ionization constant Ka greater than or equal to 1, but a weak acid has a small Ka less than 1. A strong base has a large base dissociation constant Kb greater than or equal to 1, but a weak base has a small Kb less than 1. The hydroxides of group 1A and heavier group 2A metals are strong bases. Acid strength depends on the acid's tendency to ionize. The general ionization tendency factors are bond strength of HCB, where HCB represents hydrogen bonded to its conjugate base before ionization. The weaker the bond, the stronger the acid. Another factor is bond polarity. The more polar the bond, the stronger the acid. A third factor is conjugate base stability. The more extensive the electron delocalization and charge delocalization, the more stable the conjugate base, the stronger the acid. A hydrohalic acid is represented as aqueous HX, where X represents a halogen. It is formed when a gaseous HX molecule is combined with water. Acid strength of the hydrohalic acid depends largely on its bond strength and its conjugate base stability. An oxoacid has at least one HO bond and one other central nonmetallic atom E. For oxoacids in which the central atom E is from the same group and has the same oxidation number, the more electronegative the central atom, the more acidic the oxoacid. For oxoacids in which the central atom E is the same, the greater the number of oxygen atoms bonded to E, the more acidic the oxoacid. Acid strength of an oxoacid depends on bond polarity and conjugate base stability. The water ionization constant or the water dissociation constant for the autoionization of water is Kw. It is equal to hydronium ion concentration times hydroxide ion concentration, which is equal to 1.0 times 10 to the power of negative 14 at 25 degrees Celsius. For a neutral solution, the hydronium ion concentration is equal to the hydroxide ion concentration. For an acidic solution, the hydronium ion concentration is greater than the hydroxide ion concentration. For a basic solution, the hydronium ion concentration is less than the hydroxide ion concentration.